The second term is molality. The symbol is small m. Now this is defined as the number of moles of the solute present in per 1000 grams of solvent. See, when we realize that molarity is not a good term in terms of the temperature variations, we thought it's better to express the number of moles in terms of the mass of the solution. But then we realize that if we are taking the mass of the solution, we always have to add the mass of the solute to the mass of the solvent in order to get the mass of the solution. Again, if your solute is gaseous or liquid, we need to know the densities, then it can be a problematic. So we eliminated those problems and we gave the term that the number of moles will be taken in per kg of solvent or in per 1000 grams of the solvent, not the solution. This is most important. And therefore, the term molality originated. So, molality is number of moles of the solute same and B per kg of the solvent or per 1000 grams of the solvent. What is this WA here is? The WA is the weight of the solvent, and it is in this case is expressed in terms of kilograms. If it is expressed in terms of grams, to change it into kilograms, what we will do is we will multiply it by 1000 and now your formula becomes this much. So in this case, your weight of the solvent is in terms of grams. So this is the formula. We can expand this number of moles also again, like we have done in case of molarity. So this formula becomes weight of solute, molar mass of solute, 1000 upon weight of solvent. So this is the formula of molality. And from here we can make out its unit will be moles per kg of the solvent, of course, which is in short called molal. Remember, molarity is called molar and it is called molal, LAL. So that's the difference. So this is the molality, and out of these two terms we always prefer to use molality. The reason is it is depending upon the mass of the solvent and not on its volume, so it will never vary with the temperature. Now let us do a numerical on molality. The numerical is find the molality of a urea in a solution having 18 grams of it in 100 ml volume, and density of the solution is 1.08 grams per cc. See, we are given weight of solute as 18 grams. We know molecular mass of the solute, see, urea is NH2CONH2. So it's 14 and 2 16, 16 makes it 32, and we will have here 16 again here 48 and 12 makes it 60. So it's 60 grams per mole is the molar mass of the urea. But what is important is we are given volume of solution as 100 ml and the density is also given to us 1.08 grams per cc cubic centimeter. Now how to find out molality? See, let us put this terms in these values in the formula. The formula is weight of solute divided by molar mass 1000 upon weight of solvent. Weight is 18, the molar mass is 60, into 1000 is fine, but we don't know what is the weight of the solvent. Weight of the solvent can be determined from this information, which is the solution. Now for solution, we know what its density is always mass by volume. So its mass is density into volume. Density is 1.08, volume is 100, so it's 108 grams. Remember, 108 grams is your mass of solution, which is actually having volume 100 ml. Out of this, 18 grams is your urea. So what you get is 90 grams is the water which is there. So what is the weight of the solvent? Here it is 90 grams. So we'll put 90 here. So it is 60, 18 is 0.3. We'll make it 300 by 90. So it will be 3.3 molal. So it is this is the answer in this case.